Unit 4 is all about rational functions, rational expressions, rational equations, but all this rational business simply means you're going to be working with fractions, and they're going to be ugly fractions because not only are they going to have numbers in them, but they're going to have variables in them also. So let's start with example number 1. Just simplify this rational expression, or as it's more commonly known, at least in my class, simplify this ugly fraction. Now, let's start with restricted values. A fraction cannot have 0 in the denominator, because if it does, it would be an undefined fraction. So, looking at this fraction, there is a way there could be 0 in the denominator. And if that is a had a value of 7, because 7 minus 7 is 0. So we already know our restricted value. A cannot equal the value 7. Because if it did, 7 minus 7 is 0, and suddenly we would have an undefined fraction. We don't want an undefined fraction. So, what is the reduced fraction right here? Well, the numerator needs to be factored. There's going to be a lot of factoring in this unit, just like there was in the last unit. So I'm going to factor the numerator. It's a trinomial. My factors of negative 21 that add up to negative 4 are a minus 7 and a plus 3. That's my numerator factored. Now the denominator down here, it really can't be factored because it is what it is. It's 7 minus a. Now I do have some reducing that I can do. A minus 7 and 7 minus a are perfect opposites. So I can cancel them or reduce them. And when they reduce, since they're perfect opposites, they reduce to negative 1. And so your final answer would simply be the opposite of a plus 3. And the easiest way of writing that would be put the negative sign in front of the a plus 3. And that would be your answer. Now the next one. Simplify and identify any excluded values. Now on this one, notice both the numerator and the denominator need to be factored. So before we can figure out what value or values of x would cause a 0 on the denominator, we need to factor. Now the numerator is a factor by guess and check. 7x squared, there's only one way of getting that, and that would be make one of them 7x and the other one x. So if you started your FOIL, 7x times x is definitely 7x squared. But now, at the end of the FOIL, we got to figure out what are the factors that create a 6 right here, but they would also create a positive 23 right there. And when you go through all the possibilities, you wind up with 7x plus 2 and x plus 3. Now you know that's right because 7x times x is 7x squared, so the front works. 2 times 3 is 6, so the back end works. What really matters is, do we get that 23 in the middle? And we do, because the outside and the inside. 7x times 3 is 21x, plus 2x is 23x. So if you were to FOIL this, you would check and you would make sure that you get that. Now, down here on the bottom, this one's a little bit easier. There is no leading coefficient up there. And you're just looking for factors of negative 3 that add up to positive 2. So x plus 3 would be one of them, and x minus 1 would be the other. Now, let's do our reducing. This x plus 3 can reduce with that x plus 3. And you're left with, as your answer, 7x plus 2 on the numerator over x minus 1 on the denominator. Now, don't even think about canceling those x's or reducing those x's, because binomials only reduce with the same binomial. The only thing that can reduce with an x minus 1 is another x minus 1, or maybe a 1 minus x if it's the opposite. So that's the answer right there. But let's not forget about our excluded values. Go back and look at our factored form of the denominator, and that'll tell you what our excluded values are. If our factors are x plus 3 and x minus 1, then we know x cannot equal negative 3, because that would make a 0 right there. And we also know it can't equal positive 1. So those are my excluded values in the problem. Now, moving on to example 3. The numerator is simply a monomial, so that can't be factored anymore. So 32a cubed is going to stay up on top. Now the denominator, we got this binomial going. Check for a GCF, and you'll see that both terms have an 8a. So 8a is my greatest common factor, and I'm left with 2a minus 1. So now I can start reducing. The 32 over 8 simply reduces down to 4, because 32 divided by 8 is 4. So the 32 is going to go away, the 8 is going to go away, I'm going to put a 4 right there. Now the a cubed divided by that a. All that a is going to go totally out, and it's going to reduce that a cubed down to a squared. And I think that gives us our answer. I think we're done reducing. 4a squared is our numerator. And our denominator is simply the binomial 2a minus 1. Now let's look at our denominator to see the excluded values of a. What values of a would cause us to get a 0 down here? Well, even though the entire 8a went away, we need to consider it. Okay? If 8 times a, if a equaled 0, then 8 times 0 would be 0. So a is 1, or 0 is one of our excluded factors of a. A cannot equal 0. But this factor gives us an excluded value also. If you make an equation 2a minus 1 equals 0, and you solve that equation, you're going to find that the value of a is positive 1/2. So those are my two excluded values of a. A cannot be 0 in this problem, and a can also not be 1/2. Okay, our last example for right now is example number 4, which is in function notation. We have defined an f of x function, and we've defined a g of x function, and we're doing some division. So f of x over g of x. So we've got m squared minus n squared over m squared plus 11 mn plus 10 n squared. So this just comes down to factoring again. I need to factor the numerator. This is a difference of perfect squares. So m plus n multiplied by m minus n. That's how my numerator factors. Now my denominator is a trinomial. It begins like most normal trinomials with m squared. So this would be m and another m right there. Now don't let this n get in the way, because we're just going to put the n in afterwards. What if the n squared wasn't there and the n wasn't there? What are the factors of 10 that have a sum of 11? Well, one of them would be plus 10, and the other one would be plus 1. But we need to get those n's in. So I need to put an n there, and I need to put an n there. So now everything's factored. Now start reducing. This m plus n is the same thing as m plus 1n. So they reduce. And really, that's all we've got. M minus n over m plus 10n. And on this particular problem, don't worry about the restricted values. Because if we would, we'd have to actually concern ourselves with what m cannot be and also what n cannot be. So we're not going to worry ourselves with both of those variables. Example number 5. We have ourselves another ugly fraction. And if I need to simplify this fraction, that simply means I need to factor it, and then I need to reduce what I can. So this numerator is a sum of perfect cubes, so we need to remember how to factor sums of perfect cubes. The first factor is a binomial, so I'm going to make a smaller set of parentheses. And the second factor is a trinomial, so I'm going to make a larger set of parentheses. And I'm going to use the acronym SOAP to tell me what signs go where. Same, opposite, always positive. And now I'm just going to fill in with the coefficients. This is x and this is 5, because x cubed is x cubed and 5 cubed is 125. So this is made up of x and 5. Now the pattern goes, I need to take this and square it. The middle term is one of each, so x times 5 is 5x. And then the last term is this squared, so that's 25. So that's the numerator factored using differences of perfect cubes. Now let's worry about the denominator. Well, the denominator is simply x plus 5. We don't have to worry about it. There's no way to factor that. It is what it is. So now it's time to reduce. This x plus 5 cancels with that x plus 5. And we're simply left with the trinomial x squared minus 5x plus 25 as our answer. That's our answer. Now let's go back to restricted values again. This one's pretty easy. There's only one value of x that would produce a 0 down in that denominator, so that's the one value of x that we have to avoid. X cannot equal negative 5. Because if it did, we'd be in trouble, because we'd have a 0 down on the bottom. for problem number 6, we're back to function notation again. We're taking v of x and we're dividing it by w of x cubed. Now, they're both defined for us, so we're actually taking x squared plus 5x minus 2x minus 28. Now, we can simplify this right now because of the idea of combined like terms. We can rename v of x as being x squared, and that would be plus 3x minus 28 over. Now, I'm going to take w of x, which is 4 minus x, and I'm going to present it as being cubed, but I'm not actually going to expand it. I'm not going to take 4 minus x and multiply by 4 minus x and then multiply by another 4 minus x, because it would be this long, ugly polynomial. It wouldn't simply be 4 cubed minus x cubed. It doesn't work like that. You can't distribute an exponent to a polynomial like this. You can if it's a monomial, but you can't to a polynomial. Now, we're going to take the numerator, which needs to be factored. The factors of negative 28 that have a sum of positive 3 are x plus 7 and x minus 4. That's the numerator factored. And all I'm going to do down here is I'm going to put 4 minus x, and I'm going to put another 4 minus x, and I'm going to put another 4 minus x. And the reason I wrote it 3 times is because one of them, well, all 3 of them are the exact opposite of x minus 4, but only one of them will reduce. So I'm going to take this x minus 4 and reduce it with any one of these 4 minus x's. It really doesn't matter which one. But since they are perfect opposites of each other, they reduce to make negative 1. So my answer to this problem would be the opposite of x plus 7, just get that negative sign out there in front, over 4 minus x quantity squared. And that would be your answer. Now let's go back to restricted values. Look in the domain, look in the denominator, and figure out what value or values of x would produce a 0 down here. Well, that simply tells us x cannot equal the number positive 4. Because if it did, 4 minus 4 would be 0, and we can't have a 0 down there. Now, example number 7, equivalent fractions or equivalent rational expressions. So, write a rational expression with a denominator of 5c that would be equivalent to 14 over 10. So, what we're going to do is this. We're going to say, what is 14 over 10 rewritten as if it had to have 5c as its denominator? So my only missing value is, what would the numerator be if 5c had to be in the denominator? So this is the way I'm going to set it up. And I'm going to cross multiply. So 10 times x is 10x equals 14 times 5c, which is 70c. And I'm solving for x. So I'm going to divide both sides by 10. And I'm going to be left with x equals, and then 70c over 10 is 7c. Now remember, that's what my numerator would be. The problem wanted the entire rational expression. So the problem wanted, what is the entire fraction that would be equivalent to 14 over 10, knowing that 5c is the denominator? Well, all you've got to do is now take that 7c and remember that that was the numerator that we just figured out. And 5c is the denominator. So that would be the answer. Now let's move on to this one. If they gave us d over c and they wanted us to rewrite it as a new fraction with 5c as the denominator. So that's the way we set it up. Now cross multiply again. C times x is cx equals 5cd. Now solve for x. So I'd be dividing both sides by c. And I'd be getting a value of x as x equals 5d. So if that's the numerator that I would need, then my fraction would be 5d over 5c. Now the last one, 1/3 of dc. So 1/3 of d over c equals something that has to be over 5c. Because remember, the whole problem was all about what does the numerator have to be if the denominator must be 5c. So left-hand side, 1 times d is d. So now we've got d over 3c, I'm just multiplying these two, equals x over 5c. Now, do what we did with all the others, cross multiply. So 3 times c times x, 3cx equals 5cd. I'm solving for x, so I'm dividing both sides by 3c. Threes reduce and go away. The c's reduce and go away. They really become 1. The c's reduce and become 1. And I'm left with an x equals 5d over 3. See that? 5d over 3. Now that's my numerator. So 5d over 3 over 5c. And that's it. That's worksheet 1.